Morning. It's Saturday. Um, I'm going to go over your review sheet. Okay. What better way to spend a rainy Saturday morning than doing this? Not. Kidding. But let's get to it. And cheerleader is finally over. Yay! One day you guys will serve too. But that's another topic for another day. Okay, so one. What percent of the grid is shaded? So you have to know what the question is asking you here. The question says percent. What percent? Percent means something out of 100. So if there were 100 things, in this case, how many of them were shaded? So here you have a 10 by 10 grid, 10 squares going down, 10 squares going across, giving you a total of 100. And you want to know how many of them were shaded. So in this case, if you count, you'll find out that it's 24%, because 24 of the boxes are shaded. Okay? So that's what percent means. Okay? So that's one. Question two. What decimal is equal to 13 over 25? To change a decimal to a fraction to a decimal, we divide. So we're going to take 13, the numerator, divided by 25. And 25 doesn't go into 13, so we're going to do this, add a 0, add a decimal, which allows us to add a 0 here. 25 goes into 135 times, which is 125. If you subtract, you get a 5 left over. We're going to bring another 0 down. And 25 goes into 52 times, and that leaves us with no remainder. So our final answer, 0.52. So to change a fraction, remember, you got a fraction to a decimal, you have to divide numerator by denominator. Okay. 3. 5 and 7/9, which is a mixed number. You want to change it to any proper fraction. So let me write it over here. And what I do is I like to add these two operations, so it reminds me of what I'm doing. Okay. If you want to put an arrow like this, you can. So you're going to go clockwise. So first thing you do is 9 times 5, which is 45. You add that product to 7, gives you 52, and our denominator stays the same, over 9. So if you want to check your answer, 9 goes into 52 5 times, that's correct, which is 45. And you have leftover of 7, which is our numerator here. Okay. 4. Number there is 27, and I got cut off a little bit. 27 over 5, and we want to change that to a mixed number. All right, change that to a mixed number. We divide 20 and see how many times 5 goes into 27. 5 goes into 27 5 times. So that becomes our whole number. Let's multiply. 5 and 5 is 25. If you subtract, you get a 2 left over. And then a 2 left over, a remainder, becomes our numerator. And our denominator stays the same. If you want to check, you multiply and you add on top. 5 times 5 is 25, plus 2 is 27, which is our number over here, and our denominator remains the same. 5. 7/12 is a decimal rounded to nearest hundredth. Careful here, nearest hundredth is, well, let's divide. Change a fraction to a decimal, you divide. Numerator by denominator, 12 does not go into 7, so let's add a 0, let's add a, oops, no, forget that, add a 0 at the bottom. 7 goes into 12 5 times, which is 60. You subtract, you get 10, you add, let's bring another 0 down. 12 goes into 100 8 times, and that's 96, okay? And you have 4 left over. Now, you're going to say that some of you might stop over here. Please don't, because if you want to round it to nearest 100, you need one extra number, okay, to see if it's going to make the 8 stay or 8 go up 1. Okay, so in order to round, you need that extra number on the side. That's why we're going to go one more number. So bring another 0 down. 12 goes into 40 3 times, and that's 36. And we can stop right here. So we could have gone on, but we don't need to, but because we only need that extra number here, the thousands place. Basically, rounding to nearest 100 says, let's cut that decimal right here. In order to round, I need this extra number, okay, to decide whether it's going to influence the 8 or not. So remember, 4 less, let it rest. 5 or more, let it score. So because the 3 is small number, okay, less than 5, that 8 stays as it is, and it's not going to change. So final answer, 0.58. So 0.583 rounded to the nearest hundredths, which is right here, is 0.58, giving our answer of B. Written as 0.64, written as a fraction in simplest form. Okay, simplest form, ladies and gentlemen. So let's change that to a fraction first. And did I just do that incorrectly? Yes, I did. All right, give me a second. I meant to write 0.64. And how do we change that to a fraction? Well, we look at the last place value, which is 4. Place value, which is the hundredth. Okay, so that's what you write as a denominator. And the numerator is that number on top, is out the decimal. So it's 64 over 100. Now we have to simplify because that's what the question is asking. So we can divide this by, we can always divide it by 2 if we don't know a higher number. So 64 divided by 2 is 32, and 100 divided by 2 is 50. That's still not in simplest form, so I'm going to divide that again by 2 and 50 by 2, so giving us 16 over 25. And that cannot be simplified any further. So final answer, we have C. Okay. 7. When writing 64.1 as a decimal, it equals 2. So we want to change a percent to a decimal. So step 1 is eliminate the percent sign. Get rid of that because you want to change it to a decimal. Step 2 is move that decimal, which is right here for now, 2 spaces to the left. So to clean that up, I'm going to write that. So here's my new decimal place, and I'll copy the rest, 64.1. Oops, let me write that. That's a mistake. It's 64, 0.641. Remember, I moved that decimal from there all the way to the left. And I'm going to add a 0 here as a placeholder, so it looks prettier. Final answer is 0.641, which gives us B. 8. 64 written as a fraction is simplest form. Okay, so 64%. How do I change a percent to a fraction? Remember, percent is something out of 100. So this means that there were 100 things, items, questions, and 64 of them were chosen, shaded. So something out of 100. So out of 100, 64 things happened. Okay, so that's how I change a percent to a fraction. Now we need to simplify it. And these numbers look very familiar 2 questions ago, 64 over 100, and back then we divide that by 2 and then by 2 again, so we got final answer 16 over 25. Okay, which is C. Okay, 64 over 100. 9. The absolute value of negative 75 is, alright, so let's go over absolute value for a second. Here's my number line. Here's 0, and let's find negative 75, which is somewhere around here. So the question says, what's the absolute value of negative 75? In other words, if you were standing on top of negative 75 right here, how many spaces or how many units, how many steps would it take for you to go all the way back to 0? Obviously, if you're set at negative 75, it would take you 75 steps. Okay. Remember, distance cannot be negative. You can't say you walked negative 75 steps back to 0. You took 75 steps or spaces or units to 0. Okay, that's why our answer is positive. Okay, because the distance cannot be negative. Okay, so basically, absolute value is literally asking how far are you away from 0. 10. The integer 9 or positive 9 can be used for which statement? Well, positive 9. Okay, so let's see what we have here. A, he lost $9. Losing has a negative connotation. Okay, so we can't use this for positive 9, so A is gone. B, he earned $9. He made, you're gaining $9. So that has a positive connotation, which means we can use this one. Let's check the other two. He dove 9 feet underwater. Going underwater means negative. Okay, so can't use this one. And again, 9 degrees below 0. So if you're below 0, you're in negative territory. We can't use that either. So final answer, B. He earned $9. 11. 23% of 64 is, good question. Let's see. I'm going to show you, let's try 2 ways. So 23%, and actually it's percent proportion. 100 goes here. The percent goes over 100. Of 64, which means 64 is the total. That goes down here. And we want to know, out of $64 here, how much did we spend? We spent 23%. So what is that equal to? There is no direct relationship here. Nothing multiplied by 64 gives you 100, or vice versa. Nothing divided by 100 will give you 64. So you'd have to change this. If you were going to use a percent proportion, you're going to have to change this somehow. Can't change this ratio, but we can change this ratio. So a long way of doing this is to change that. So let's write 64, because that's not going to change. So what can I change this so that there is a relationship with 64? Well, the only one that I know of is going to be 6,400. I multiply 100 times 64 to make 6,400. And if I multiply that by 64, I must multiply that by 64. And 23 times 64 is going to be 1,472. Okay, now there is a relationship. Okay, there is a relationship. 64 and 6,400. Okay, it's either, if you go one way, it's times 100. If you go backwards, 6,400 to 64 is divided by 100, which is what we're looking for. So it's 6,400 divided by 164. That works. And then here, obviously, you're going to have to divide by 100 as well. And 1,472 divided by 100 is 14.72. So your answer is C, but no, your answer is A. That's our final answer. But I'm hoping that you are going to avoid this method and instead do the other one that we went over in class. 23% of 64. Okay. So we want to find out what 23% of 64 is. Remember, the other way was changing this to a decimal. 23% as a decimal is 0.23. Of means multiply, and 64 stays at 64. So now you can take your calculator, or you can do it on the site, and you get that when you multiply this, it's 14.72. Okay? I would suggest for this particular problem, this is much easier and simpler to do. Okay? Only because these numbers here, the denominators, there was no initial relationship, so you had to change it to a huge number, okay, and made things a little bit more complicated. So choose the right side, okay? Change it to a decimal and then multiply for this particular problem. 12, order from least to greatest. Okay, let's see. Let me just move this up a little bit. Okay, so order from least to greatest. Well, what I would do first, why don't we write all of them, okay, under each other, line them up. So negative 5.02, and you line decimal under decimal, guys, when we're talking about decimals, because you want to make sure you're comparing numbers properly. So that's negative 5.2. Third one is negative 5.22. And fourth one, negative 5.002. And finally, negative 5.222. Okay, you'll notice that there are some decimals there that do not have the same amount of digits. So I'm going to add a 0 here. So that, and a 0 here, a 0 here, and a 0 here. It doesn't change the value of the number. Okay, so now they all have the same number of digits. So remember, you have to remember one thing. With negative numbers, the bigger the number, the smaller it is. Okay, it's backwards. Okay, so let's try to order these numbers. Okay, so what's the biggest number that you see? So if you can imagine for a second, not imagine, okay, ignore the negative signs for a second. So pretend these negative signs are not there. Pretend even the decimals are not there. So for a second, imagine that there are no decimals here and that there are no negative signs. So what would be your biggest number? Well, the biggest number would be 5,222. Second biggest number would be 5,220. So let me make a check here. Okay. The third biggest number would be 5,200. Fourth biggest number would be 5,020. And the fifth biggest number would be 5,002. Now I'm going to actually put the decimals back where they're supposed to be, and I'm going to put the negative signs. So, like I said, order from least to greatest. No, like I said, the bigger the number, the smaller its value when we're talking about negatives. Okay, so the biggest number was this, 5.22, which makes this our number with the least value. And obviously our smallest number, when we talk about negative, makes it the greatest. And everything else is in order from least to greatest. Okay, so there's a little trick that you might want to use. 13, order from least to greatest. Again, so and in this one, let me just do this. I'm going to change 2 1/4 to 2.25. Okay. And in this one, you know what? You might want to. I'm going to use a number line. Okay. 0, 1, 2, and on the other side we have -1, -2. First number, -2.2. See here, 0. You're walking to the left. You're increasing 0, -1, -2, and you're going up. -2.1, -2.2 should be about here. Second number, 2.25 positive. So in this case, we're going right. So as we're walking to the right, we increase here. 0, 1, 2, and 2.25 is a little bit on that side. -0.8. Here, 0. We're going to the left. 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. 0.8 should be just about here. 2.3 positive. We're going to this right. Here's 0. That's 1. That was a 2. This is 2.25. Think about money for a second. $2.25 and $2.30 should be just right after that. -2.1. We're going to the left. 0. That's -1. That's -2. And -2. And then -2.1, which should be a little before -2.2. 0.8, let's think about that. That means 80 cents. So here's 0. That's $1. 80 cents should be about here. -1.9, here's 0. We're going to the left because it's negative. 0, -1, and -1.9 should be a little bit less than -2. And here is your order. So your order would be -2.2, -2.1, -1.9, -0.8, 0.8, 2.25, and then 2.30 as your biggest number. So that's least to greatest. Okay, he didn't ask you to use a number line, but I just did it. Okay, so you have choices. 14, use a less, greater, or equal sign to complete each statement. So, all right. So let's take the first one. 2/5, 1/6. What's my problem here? Well, one of the main problems here is that the denominators are different. It's very hard to compare. I don't know if 2 over 5 is greater or less than 1 over 6. Okay, if there was a pizza cut into 5 pieces, 5 slices, and you got 2, would that be greater than taking a slice out of a piece that was cut into 6 or less? Well, step 1, I would, and you should, change the denominators so that they are the same. So instead of having one that's instead of them being different, I would make them the same. So think of a number that 5 and 6 can both go into. Okay, and we're talking now about LCM. So if you want to do LCM on the side, 5 and 6, these common multiples, so you would go 5, 10, 15, 20, 25, 30, 35, etc., etc. 6, 12, 18, 24, 30. Ooh, look at that. We have a common number. So that's 30, and that's 30. Now, how did a 5 become a 30? It was times 6, so I have to do the same to the top, which is times 6. That gives us 12. 6, how did it become a 30? It was times 5, so therefore the top times 5, which gives us 5. Now, it's much easier for you to determine which one's greater, 12 or 30 and 5 or 30. So if you have something cut into 30 pieces and you got 12 and somebody got 5, who got more? Obviously, this guy. So 12 or 30 is greater than 5 or 30, or 2 over 5 is, in this case, greater than 1 over 6. Okay, so that's the steps that we're going to have to take. Okay, so let's try B. In this case, it's negative. That's okay. So first thing I want to do is the same steps, 3 over 8, and then negative 5 over 12. So step 1. Think of a number that 8 and 12 both goes into. If you do the LCM, it's 8, 16, 24, and 12, 12, 24. So both of them go in 24 nicely. 8 times 3 is 24, so I multiply the top times 3, which gives me 9, and in this case gives me negative 24. 12 times 2, which is 24, so therefore the top times 2, and then negative 10. Okay, so which one is it greater, less, or equal to? In this case, obviously, negative 9. So with negatives, and you know what? I think if I do a number line here, it's going to be easy for you to watch. So here's 0. Here's negative 1. Okay? Negative 9 over 24 is obviously less than 1. It's not a full thing. So imagine from 0 to 1, it was cut up into 24 pieces. Now I don't know if I can do this, but let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 24 would be negative 1. Okay, so here's 0 and negative 1. 9 would be 1, 2, 3, 4, 5, 6, 7. 9 would be right here. Negative 9 over 24. And obviously negative 10 would be the following one. So you want to compare and see which of these two numbers are greater. What did I tell you in class? The number on the right will always be greater. Okay? But this number, negative 9 over 24, is on the right side, is greater than the other one. So 9 over 24 is, in this case, greater than negative 10 over 24. Remember, with fractions, with negative numbers, the smaller the number, in this case negative 9, the bigger the value. Okay? So where was that? That one is greater. Okay? C, negative 3 over 5 and negative a half. Okay? This one I'm going to do it differently. Yes, you can change it. You know what? I'll do it both ways. The LCM between 5 and 2 is 10. 5 to get to 10 is times 2, and this top is times 2. And you get negative 6. 2 times 5. And on top times 5, you get negative 5. So, in this case, remember negative, because the negative numbers, the bigger the number, the smaller it is. So this is actually smaller than the other number. And this is like that. Okay, negative 6 over 10 is less than negative 5 over 10. Okay, I'm going to use the next problem to do it the other way. So with 9 over 10, 11, 13, yes, you can change it to two fractions where the denominators are the same. Or another way, if you're not too comfortable with that, is to change this to a decimal. 9 over 10 as a decimal, okay? Very easy because our decimal is 10, so we know it goes to the 10th place, and here's a 9. So 9 over 10 as a decimal is 0.9. 11 over 13 as a decimal, well, this one's not as simple, so you actually have to divide. So 13 goes into 11, nope, add a decimal. 13 goes into 110 8 times. 8 times 3 is 24. Carry the 2, and that's a 10. And you have a, oh no, that's crossed as a 0. You have a 6 left over. And if you want to bring another 0 down, you can. 30 goes into 60 4 times, which is 42. No, 5 times. Wait, 5. No, 4 times. No. So be 4 times, yes. 42. 13 times 4 times 3 is 12. Goes 152. My apologies. Okay, there was my mistake. So as a decimal, 0.84. Or actually, it continues on, but we don't need to go as far. So we have one decimal. We could have stopped at the 8 actually. 0.9 as one decimal, and 0.84 blah 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 on the other decimal. So which one is greater? This one, it's very easy to see that this decimal is bigger than the other decimals. Okay, so if you thought about money even, this is 90 cents, this is 0.84 cents. Okay, 90 cents is greater than 84 cents. So you have an option there. If you don't like to find the LCM, you can change both of them to a decimal to compare. 15. Justine scores 6 out of 20 on her quiz. What percentage is that? Okay, very simple. I guess the point of this question was to just make sure that you know the percent proportion. That's 100. We want to know what percent she got. And here she got a 6, which is the part out of a total of 20 questions. So she didn't do too well. Oh, look at that. Very easy one. Nice relationship between 20 and 100, which is times 5. And therefore, you got to do the same thing on top, which is times 5, giving you 30%. So she scored, or she got 30%. Okay? 20 out of 40 people like chocolate. What percentage likes chocolate? Again. Okay? You want the percent. That was question mark over there. 12 is a part. 12 out of 40 total. So here, you have to make some. There is no relationship between 40 and 100. Well, there is one, 2.5. But if you didn't see that one, I get the point of this particular problem is to make you change this ratio right here. Okay, so that there is a relationship. The easiest one, and you should see this by now very fast, is that to divide top and bottom by 2, you get 6. And what is this? Remind me later. Divide that, and you get 6 out of 20. And to then find your answer, again, times 5. 20 goes to 25 times. Nice, pretty relationship. And then you multiply the top by 5 again, and you get 30. So, what percent like chocolate? So if you had 40 people in the room and 12 said they like chocolate, that would equal to 30%. So the point of the question here was that you needed to change the 12 over 40 to something. Okay, in this case, simplify it to 6 over 20. Okay, you could have even done 3 over 10. Okay, so simplify that again, and so that there is a nice relationship between each denominator. 17, 56% of the 75 kids are going to the beach. How many kids are going to the beach? Okay, all right. 100 goes here, 56 go on the top, and then 75 kids over here. You got, this problem is going to be a matter of choice for you guys. Okay? No? All right, let me rephrase that. What I'm trying to tell you is, I hope that as soon as you set this, you realize that there is no relationship here. And that if you simplify this, well, 56 to 100, you simplify that to 28 out of 50. That still, there is no relationship between 75 and 50. So this particular question, okay, I would actually go the other route. 56% of 75. Okay, if there's 75 kids, 56% are going to beach. We're going to figure out how many kids are there. So that changes to 0.56, change to a decimal. You change the multiplication, and that becomes 75. Much simpler than doing all the work here. Yes, can you find relationships? Yes, you can, but sometimes it's simpler to do it the other way. 56 times 75, and a grand total of 42 kids are going to the beach. 42 kids are going to the beach. There we go. Okay. 18. 60 people went shopping. 35% bought hats. 1/4 of the group bought sweaters. How many did not buy anything? Okay, so all right, let's start with our first. We got to find out how many people bought hats. So here's our percent proportion. Let's start with that. Let's see if that works. 100% goes on top, and 60 goes at the bottom. Here, because total of 60 people, we want to know how many of them bought hats. No relationship between 60 and 100. If I divide that by, if I change this guy by dividing it by 5, I get 20 over here and 7 over here. So there is a relationship. Oh, look at that. So I divide that by 5. I divide that by 5. Okay, so in this case, reducing it did help. 20 goes into 60 times 3, and 7 would be times 3, and our number is 21. So 21 people bought hats. 1/4 of the group bought sweater. Well, 1/4. So you had a group of 60 people. I'll draw this. Here's 0. Here's 60 people. And 1/4. Well, 1/4 means that the group was broken up into 4 pieces. Okay, so 4 pieces. Each piece is 15. This is 15. That's 1/4 of the group. That's another 15 would be 2/4 of the group, and another 15 would be 3/4 of the group, and another 15 would be the entire group. So if there was a group of 60 people and 1/4 of them bought sweaters, it means that, again, 60 broken into 4 pieces, it means that each piece is 15. So 15 bought sweaters. So let's add that up. We found out over here that 21 bought sweaters. Bought hats. 15 bought sweaters. If you add them up, you get 36. How many people bought nothing? Well, the total was 60. 36 people bought a particular item. If you subtract, you get 24 people. 24 bought nothing. Okay. 19. Complete the chart below. Okay, so let's start. 0.72 as a decimal. It's a decimal. We changed to percent. So remember, we got to move the decimal to the right. 1, 2, and that becomes 72. Add the percent sign. Easy enough. 72. We're gonna change that to a fraction. So just erase that here. Change it to a fraction. Well, I look here at my last number. that is in the hundreds, so it's 100 over 72. And I always will simplify this, and in this case I'll get 18 out of 25. Okay, divide top and bottom by 4. That was easy. 24% as a decimal, sorry. So you remove the percent sign, there's a decimal right here, and this time we're going to the left. So 24% as a decimal is 0.24. Okay, this is my new decimal place. And then again, this as a fraction, well, the 4 is in the hundredths place, so that's 100 at the bottom and 24 on top. Divide by 4. 24 divided by 4 is 6, and 100 divided by 4 is 25. So our final answer, 6 over 25. Next one, 4 over 10. Well, 4 over 10 means that the 10th means that that number goes up to here, and we put the numerator on top. Okay, that gives you 0.4. And we want to change that to a percent. We move the decimal 1, 2 spaces to the right. Remember, this empty space has to be filled in. So it's 4, and we add a 0, and we add the percent sign. Okay. And again, here, changing a fraction to a decimal, you could have divided too. Right? 4 divided by 10. 10 does not go into 4, so I add a 0. I add a decimal here. And a 40. And 10 goes to 40 4 times. Gives you the same answer, 0.4. Okay. And I don't know why I wrote 0.4. It's the same answer at top. Okay, so I'm going to not do this because this and this are exactly the same. 3 over 8. How do we write 3 over 8 as a decimal? Well, 3 over 8 as a decimal, you're going to have to divide. 3 divided by 8. 8 goes into, no, that's not going to 3. 0, decimal, 0. 8 goes into 33 times. That's 24. That's 6. Bring a 0 down. 8 goes into 60. How many times? 7, which is 56. And 4 left over. I'm going to bring another 0 down. And 8 goes into 45 times exactly. So that came out to be pretty. So 3 over 8 as a decimal is 0.375. That worked out nicely. And we're changing this to a percent, which means move this decimal 2 spaces, 1, 2 to the left, to the right, I'm sorry, and the decimal ends up being between the 7 and the 5, and we add a percent sign. 9% to a decimal. Well, there's the decimal is not there, so we add it right, always on the right side when you don't see it. We're moving it to the left, 1, 2, and that's my new decimal spot. So let me write the new decimal spot here. There's an empty space, which I fill it with a 0. 0 and 9, and I'm going to add a 0 in the front, okay? So it's not empty. So as a decimal, 0.09. As a fraction, well, the denominator is going to be 100 because that's where the 9 is in the hundreds place. And the number on top will be 9. Can I simplify that? Nope. Leave it alone. Ratios. Ooh, ratios. All right, so let's do ratios. The ratio of spoons to forks is 4 to 7. If there are 44 utensils, how many spoons are there? Alright, so let me draw that ratio. Let's do it. I'll do it as many ways as I can. For spoons, 4 spoons. I'll write S and 7 forks. That's the ratio that I have. And it's growing. So as it grows, the ratio stays the same. We always have to have 4 spoons, 7 forks. 4 spoons, 7 forks. And let's see, I have 11 over here, 11 utensils, plus another 11 is 22, plus another 11 is 33, so I need one more. 4 spoons, 7 forks. So, let's see, if there are 44 utensils, which is what I have right now, how many spoons are there? Well, easy enough, I just count. There's 4 spoons over here, 8, 12, 16. Final answer, 16 spoons. Okay. You can do a tape diagram for this one too. So let's do a tape diagram. Spoons and forks. The ratio is 4. So I'm going to draw 1, 2, 3, 4. And for forks, this should be an F, by the way. It's 7. Okay. 1, 2, 3, 4, 5, 6, 7. Remember, with tape, the beauty about tape diagram, once you find one number, all the other numbers are the same. Well, here is my ratio, 4 to 7, and we have 44. Well, what happens when there's 44 in total? Well, this 44 has to go inside all those squares evenly. So 44 divided by 11, no, 44 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 means that each box over here is 4. Okay, so, and that, if you count the number of spoons, you got 4, 8, 12, 16. Same answer as we got before. Another one is to do a proportion. Let's see what we have. We want to know what happens when there's total 44. How many spoons? That's our question. On the other side, we have to match it. Okay, bottom number here has to be a total, and the top number has to be about spoons. Okay, always has to match side by side. So total, when there are 11 here, okay, when there's 11, how many spoons are there? Well, when there are 11 utensils, 4 of them are spoons. So again, now easy relationship, 11 to 44 is times 4, and 4 to our magic number is going to be times 4, giving us 16 spoons. Okay, so there are 3 different ways, and you're welcome to choose any of them. 21, the ratio of chocolate candy to strawberry candy is 3 to 8. If Jill wants to buy 36 candies, how many strawberry candies does she need to keep a proportion? Alright, so here, 3 to 8. 36 chocolate candies. Alright, so we can do this with, alright, what's our right? Our ratio is 3 chocolate, 8 strawberry. Okay, so what happens when there is 36 chocolate? Alright, so let's grow and see what happens. 3 chocolate, 8 strawberries, and keep going, because I need to find out how many strawberry I will have when I have 36 chocolates. So far I don't have enough. Another 3 chocolates. Keep going. 3 chocolates, 8 S. 3 chocolate, 8 strawberries. Let's see how many I have. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, and finally 36 chocolates. So if you count all the C's, which is 3 C standing for 3 chocolates, each group had 3 chocolates. If you count, I will have 36 chocolates here. Now, what happens when I have 36 chocolates? I'm going to have 8, 16, 24, 32, 40, 48, 54, 60, 68, 68, 76, 84, 92. No, there's something wrong there. Oh, you know what? I'm going to do the easiest way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12. So 8 times 12 is 96. Somewhere there I messed up. So 96 strawberry candies when there are 36 chocolates. So let's do this using a proportion. Okay, what happens when there's 36 chocolate? Okay, so in this case, let me erase that because that's not really. So 36 chocolates. How many strawberries? Okay, our ratio was 3 to 8. 3 chocolate for every 8 strawberries. Okay, so again, there is a relationship here, which is times 12. And here will be also times 12, giving us 96. You can also do a tape diagram for this. And you have 1, 2, 3 for chocolate, and you have 8 for strawberry. 1, 2, 3, 4, 5, 6, 7, 8. So okay, 1, 1, 1. So 3 chocolate candies, 8 chocolate. Rephrase: 3 chocolate candies. There we go, and 8 strawberry candies. So that's our how you would set up initially your tape diagram. And then now we know that there are 36 chocolate. Well, there's 36 chocolate. Well, there's 36 chocolate in 3 spaces here. You would fit 12 in each, 12, 24, 36, which means every other box has 12 as well. And 12 times 8 up here would be also 96. Perfect. Okay. 12 oranges for $6 as a unit rate. All right, as a unit rate. Well, okay. Money, I like to put money on top. Makes life, I think, easier to see. Okay, 12 oranges. So how do I write that as a unit rate? To change that to unit rate means we're comparing it to one item. So instead of 12 oranges, I want to know what the price is for 1 orange. How does a 12 become 1? Times 12. I'm sorry, divide by 12. So the top has to be divide by 12. So 6 divided by 12 in this case gives you 0.5. So you can say that every orange is for 50 cents for 1 orange, and that's how you write a unit rate. Well, let's hang on 1 second. So this one, okay, just for you to practice again, 420 miles. Remember to write the units, miles. Okay, you can abbreviate if you want. 6 hours, 6H. Don't write that as a unit rate. Again, we want the denominator to be 1 hour because we're comparing to 1 unit. 6 to 1 is divide by 6. That gives us 1. And then we have to do the same on top. And that should give us 70 miles. So you can say 420 miles in 6 hours or 70 miles in 1 hour. Ooh, okay. Why do we use unit rate? Well, one of the things you can use it is to compare. Okay, so let's find a unit rate for each one. So 10 ounces for 124. So $1.24 buys you 10 ounces. How much did it cost for 1 ounce of OJ in this case? So you're going to divide that by 10 and divide that by 10. And that gives you about 0.12 cents. Okay, it's going to give you 0.1124, but if you round it, money only goes to 2 decimal places, right? So it's 12 cents. Second one, it's $2.15, and you buy 22 ounces of OJ. And again, we're going to make that 1 ounce. So this one, 22 to go to 1, so divide by 22. And you're going to divide the top by 22. So you get 2.15 divided by 22, and that gives you about 0. Well, it came out to be, my calculator came out 0.097. Okay, so you want to round this up. Okay, 7 makes the 9 go up 1. From 9 it becomes a 10, or 0.10 cents. Okay, and finally the last one, 40 ounces for $4.75. $4.75 for 40 ounces of OJ. And again, we want to know how much 1 ounce costs. So it's divided by 40 here. And you're going to divide the top by 40. So 4.75 divided by 40 will give you a total price of, in this case, well, on the calculator, I'm going to write on the side, came out to 0.118. And again, this one, the 8 makes that 1 go 1 higher, or round it becomes 0.12. So the cheapest one is this one, 22 ounce, right here, because every ounce of OJ, or apple juice, I'm sorry, is 10 cents. Okay, Order from least to greatest. Okay, these are all positive, thankfully. Okay, so it makes life a little bit easier. So 6.06, 6.6. So again, the first thing I want to do is line them up, decimal under decimal. Okay, 6.66, 6.006, and then finally just 6. And you can add a decimal to that because it makes no difference. So now, what you want to do is you want to make sure that they all have, I would add 0 so they all are the same size, same number of decimal places, and much easier to compare. So from least to greatest. Okay. So again, for a second, just for a second, you want to pretend that there is no decimals. The smallest number would be this guy right here because it's 6,000. Again, just pretend for a second there's no decimal. After 6,000, the smallest number would be this one, 6,006. And it would then be this one, 6,060. And then it would be this one, 6,600. And finally, it would be that last one, 6,660. Okay, but go back now and make sure you add the decimals. So from least to greatest, the smallest number would be this, which is 6. Second one will be 6.006, 6.06, and then 6.600 and 6.660. Okay, from least to greatest. Okie dokie. Let's see. 26. Is there 26? Yes. Katrina earns $15 every 4 hours. How much will she earn in 29 hours? All right, so let's set it up. So here's our proportion that we want to set. We know that she makes $15 in 4 hours. You want to know how much she makes in 29 hours. There is no relationship between 4 and 29 here, okay? But this one, remember when we did ratios, and I'm going to write this a little bit further out, right here. Okay, there's no relation between 4 and 29. So what we're going to do here is make our change. Okay. I change that to unit rate. Instead of, you know what, let me write it better. I'm going to write unit rate. Okay. That's where, so how does this become a unit rate? We find out what it is in 1 hour. 4 divided by 4 becomes 1, and then 15 divided by 4, 15 divided by 4, it's 3.75. So basically we can say that Katrina makes $3.75 in an hour. And then now we multiply. An hour to change 29 is times 29. So if she works 29 hours, it gives us $108.75. Okay, so this one you have to go from rate to unit rate and then multiply to find your final answer. Okay. 27. Why is the absolute value of negative 5, 5? Well, always easy if you draw it up. That's 0, that's negative 5. Why is the absolute value of negative 5, 5? Well, the absolute of negative 5 is 5 because negative 5 is 5 spaces away from 0. And it's positive 5 because distance cannot be negative. Okay? Let's see. The fraction negative 2 over 7 is located between which two numbers? Ooh, okay. So let's draw our number line and draw what we're given. We need a 0 because that's given to us. We need a half. So if that's 0 and that's 1, this would be a half. What else do we need? We need negative a half. Well, so that's negative 1. This is negative a half. And we need negative 3/4. Well, negative 3/4, well, it's right here. So, where is this number? Is it here? 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 Alright, so, how do we do this? Alright, one way of doing this, and I think the easiest way to do this is to change it to a decimal. So 2 goes inside, 7 goes outside. Remember, I'm changing a fraction to a decimal. I divide numerator by denominator. 7 does not go into 2. 0, 7 goes into 21 2 times, which is 14. Subtract, get a 6, get a 0 down. 7 goes into 60 about 8 times, 0.28. That should be enough for us. Okay, I'll leave it right there. But it's negative 0.28. So negative 2 over 7, it's definitely not here because those are positives. And it's between one of the two. Negative 0.28. Well, this is 0. Half means 0.50 or negative 0.5. So you can translate that. I'm sorry. You can change the half to negative 0.5. This one is 0.75. You know what? So let me just lower this and draw another number line. Just a little bit. Okay, so instead of fractions, here's 0. I'm not going to use that sign. Instead of saying half, I'm going to say negative 0.5. And instead of saying 3/4, I'm going to say negative 0.75. Okay. And finally, negative 1 over here. So we found the value as a fraction, negative 0.28. Well, negative 0.28, if this is 0, it's not between negative 5 and negative 75, and it's not between negative 75 and 1. It's somewhere over here, in this location right here. Okay, so the only answer that says between 0.5 or half, negative half, and 0 is this one. Okay? 82% of all the 280 students, 82% of all the 280 students in the 6th grade are not going to summer school. How many kids will enjoy their vacation? Okay, so you have choices here. You can either do it this way. You get 100 here, or you can do it 82% of 280. Okay, so either or. So let's see which one is easier. So here is percent goes on top, and how many students we have? A total of 280. And we want to know out of that how many are going to enjoy the vacation because they're not going to summer school. So, no relationship here. 100 times nothing whole number wise gives you 280. So, I mean, you can, okay, the number's going to get bigger if you want to do it this way, or you can just, in this case, do it this way because of the relationship being a decimal number, not a decimal number, a bigger number. So here, 82% would be 0.82 of means times and 280. So 0.82 times 280 gives you 229 kids, 0.6. Okay, so you can't have 229.6 students going to summer school, so you probably would round this off when talking about people to 230. Okay? You know what? Just for example's sake, I will do this. Well, what number can you change this to so that there is a relationship between 100 and 280? Well, first of all, let me erase this. You can't simplify this fraction right here, question mark over 280, so you can't simplify. I can't simplify this. Let's see, if I broke that down, divided by 2 and got 41 over 50, would that help me? No, because there's 50 and 280, still no relationship. But if I made it bigger, well, to make it bigger, I would make it bigger to 2,800. I changed the 100 to 2,800 because, as you can tell, there is going to be a relationship. And if this was times 280, I'm sorry, this is 28,000. I can make it 2,800. But that would give me a decimal. I don't know if you guys want to work with a decimal. No, I can make two. No. I'm right. I'm sorry. I don't know what I'm thinking of. 2,800. Okay. And then if I did that, and here's my mistake there, multiply by 28. Sorry. So I multiply 82 by 28 as well. And that's going to give me, times 28, it's going to give me 2,229. 2,296. Jeez. Okay. So, what's the relationship to 2,800 to go to 280 is divide by 10. I'm going to do the same thing on the top, divide by 10. And if I divide by 10, I get 229.6, which is the same answer that we got on this side. Okay. Better off doing it on the right side by changing to decimal. And order from least to greatest. Yay. Who made these questions? Okay. Don't answer that. Okay, again, the first thing I would do is change this to a decimal, which is 1.2. Okay. 1/5 is 0.20. Okay, so order from least to greatest. We can do it. Which way should I do this? You know what? Let's 0.2. Well, let's see if this works. 1.2. Oh, there should be a decimal here, by the way. Negative 0.1. 2.3. 0.25. Negative 1.35. And 2.03. Okay. So the other thing I'm going to do is add zeros. Add zeros so they're all the same size. And order from least to greatest. Well, the one thing I'm going to do is I'm going to take these two numbers out. 2.3, and let me go back to a dark color. 2.3, and I'm going to take 2.03 out. Because I know those two are my biggest numbers because they're in the positive side. So let's take these two guys out. Oh, and I'm sorry. No, yeah. Okay. So between these two, the biggest number is what? It's going to be 2.3, obviously, because 2.3. If you add a 0 here, it becomes 2.30 or 230 and 203. So I'm going to write 230 and then 2.03 like that. All right, and now I'm going to erase it. And a bigger eraser would have been nice. Right, there we go. So, so those are my. So this is my greatest. Okay, now I've got to work backwards. So from the numbers that I have left over, I'm going to write them again. Negative 0.2, negative 1.20, 0.10, and negative 0.25, and negative 1.35. Alright, so again, for a second here, I want you to ignore the negative numbers and okay, and think about money here. These numbers are nice if you talk about money. Okay, so the biggest number, since they're all negative numbers here, rephrase. Since the numbers are all negative, since all these numbers are negative, and since all these numbers are negative, I told you before that the bigger the number, the smaller its value. So what's the biggest number in all of these? The biggest number in all of these is this one. So that's my smallest number. Remember, the bigger the number, the smallest it is when we're talking about negatives. Okay, so that's gone. The second biggest number is this guy, negative 1.20. The third biggest number is this guy, 0.25. The fourth biggest number would be this guy right here, 0.20. And the fifth biggest number would be 0.10. Okay, so the smallest number is negative 1.35, and the biggest number is 2.30. Okay, and there are no questions. Hopefully that helps, guys. Like I said, if you did okay in these, you're gonna be fine on Tuesday. If you have any questions, email me. Use the contact form on the YOLA site. Okay, and that's it. Okay, and enjoy your long weekend.